Thanks everyone for coming to this lecture talk that will be delivered by Professor Jikang Chen. Okay, Jikang Chen now he is an associate professor in the Chinese University of Hong Kong and in the Department of Social Work. But his experience is not just in the social work. He has extensive experience in studying the adolescent health, especially the mental health and the bully issues. And also, he is very good at the statistical methods, like the structural equation modeling and different forms of structural equation modeling, like the cross-leg models or like the latent growth model. So today, we are very honored that we can invite Dr. Chen to give us his experience in conducting these structural equation modelings. And he will give us some brief introduction regarding what structural equation modeling is and what confirmatory factor analysis is. And then he will give us some demonstration using the AMOS software. Although we know that AMOS software needs money. And unfortunately, in National Cheng Kung University, we do not have that. But AMOS is a friendly software. So if you have chance, you can try to use the demo version from its company. Okay, although there are some limitations, and if you think that it is really good, you can persuade your advisors to buy it, or you can buy it by yourself. Okay. Anyway, I'm not going to waste any time of Professor Chen, and let's give a big hand to invite Professor Chen to deliver the talk of using structural equation modeling. Let's welcome Dr. Chen.
Okay. Thank you very much. Thank you, Professor Lim, to invite me to have this sharing about the AMOS and also structural equation modeling. And also, thanks for your time to attending these sessions. And also, today, I basically will focus on focus on sharing about how to operate AMOS. I use AMOS, this kind of software, for I think over 10 years. But originally, I'm not using AMOS. I originally use EQS. There are a lot of different software dealing with structural equation modeling. And when I study in PhD program, there is no M+. I understand there is another software called M+. This is very powerful too. So basically, I will focus on the AMOS today. I understand that there are a lot of other software dealing with structural equation modeling, but today I will focus on the AMOS. So before we start, I would like to just quick review about structural equation modeling. And I just give you some PowerPoints, and you may just briefly understand what a structural equation modeling, and later I will introduce a little bit about application of the AMOS. And I will use the example. I prepared 3 examples. This is based on my studies, previous studies. And I will show you, briefly show you how to operate or how to conduct AMOS. Basically, I will let you know that it's impossible you learn AMOS very well from these sessions. It's definitely not, because you need to work very hard to understand the more functions about AMOS. So today, I would like to just, my sharing just help you to give you a briefly or brief introductions, a brief understanding about how AMOS operates. So if you are more interested about AMOS, and I believe that you can find other textbook, and they will tell you how to operate AMOS. So if you expect you can be an expert to be a AMOS user after listening my PPT or after listening my demonstrations, if you have this kind of expectations, please, I'm so sorry. Don't hold this kind of expectation. Okay, okay. So now let's briefly introduce a little bit about structural equilibrium modeling. I believe that you have already heard about structural equilibrium modeling. SEM is not I would say it's not a new for this a few years. Actually, SEM, structural equilibrium modeling, has developed for a long time. I think over 20 years. What is the structural equilibrium modeling? Okay, structural equilibrium modeling is a multivariate statistic analysis. It's a statistic analysis technique that used to analyze structural relationship. In our social science area, or even though in the medical science area, we need to deal with a little different types of a structural relationship between variables. And the structural equilibrium modeling is very good modeling statistic software, statistic analysis to help us to deal with the multivariate structural relationship. That means that if you involve many multivariate variable and you want to discuss about their relationship between variables, and this is a very good statistic model that you can use, you can consider. And this technique is combination structural equilibrium model. What's the characteristic? What's the speciality? The characteristic is that it's different from the other statistic software, or it's different from the other statistic model. Structural equilibrium modeling can combine the factor analysis and multiple regression, or we say the path analysis together. And you can use a structural equilibrium model to deal with factor analysis, particularly CFA, and multiple regression or path analysis at the same time. And this method is preferred by researchers because it can estimate the multiple and interrelated dependency in a single analysis. Okay, basically, structural equilibrium model includes two models. Okay, one is a structural model, and the other is we call the measurement model. What is a structural model? Structural model is basically it focuses on the model who deal with about the structural relationship between variable. Okay, and what's a measurement model? Measurement model is a model focused on dealing with the measurement error. Okay, we understand that from the methodology, or we understand that each measurement has its error. Okay, its measurement it has its error. It's almost impossible. It's almost impossible to find a perfect measurement in the world. Okay, in terms of a social science area or in terms of medical area, if you use a survey or questionnaire, it's impossible to find a perfect measurement. That means that without any measurement error. Okay, so SEM, the measurement model, can help us to consider the measurement error in the model and to help us to combine the structural model to deal with the measurement error and to see how the model contribute to the dependent variable or mediators. So this is one of the most powerful why we use a structural equilibrium modeling. Okay. So basically, each statistic model, we have a statistic assumption. For example, regression model, we have statistic assumptions. ANOVA, we have a statistic assumptions. LCA, latent class analysis, we have a statistic assumptions. There is no exception for a structural equilibrium model. SEM has also its statistic model assumptions. That means that the structural equilibrium model, why we have the structural equilibrium model, is based on this statistic assumption. This statistic assumption including multivariate normal distribution. That means that in the SEM model, it assumes that your variable, even though the latent variable should be the normal distribution, but it's a multivariate normal distribution. Okay. And we use the maximum likelihood method to assume this kind of multivariate normal distributions. Okay, I will talk about this later. Don't worry about this. But here you have to basically understand the multivariate normal distribution in the SEM model in terms of statistic assumptions. And also, structural equilibrium modeling assumes that the statistic model should be the linearity. That means that it assumes that the relationship between the variables should be linear. Okay, I think this is similar to a regression model. Okay, so that means that if your relationship between the variable, the distribution is not linear, it's a curve. And I'm sorry, structural equilibrium model cannot deal with such a non-linear relationship between variables. And also, structural equilibrium modeling assumes that outliers should be free. Okay, that means that there is no extremely outliers in the data. Okay, that's another statistic assumption that SEM has. And also, SEM assumes that there should be a cause and effect relationship between the endogenous and exogenous variable. That means that basically structural equilibrium modeling in terms of methodology, it assumes that you build out the model, the variable should be the causal effect relationship. For example, it assumes that in SEM model, it assumes that your IV and DV, this kind of association, should be the causality, okay? Should be the causal effect relationship. Or you should be based on the theoretical causal effect relationship, okay? And also, there is other assumptions such as the model identifications and no spurious relationship. I think it can be understood easily by you. I don't want to mention a lot here. And also, a very important thing is that many people always argue that we can use a structural equilibrium model in any kind of context, but it may not be correct because structural equilibrium model is highly limited by the sample size. That means that we need to a very powerful sample size to help us to build out a structural equilibrium modeling. It means that it's not necessary. It means that we need to have a required sample size, and if you achieve this kind of required sample size, and then you have to consider structural equilibrium model. If under this kind of sample size, you can, I would say, if you use a structural equilibrium model, you will more likely to get biased results. So the sample size is also a very important requirement for structural equilibrium modeling. So basically here I list several important principles. I would say this is a principle. It's a rule of thumb. But basically, if you want to publish a very good journal, a very top journal, I will highly recommend you need to calculate the power analysis and use the power analysis to calculate the requirement sample size. And then you consider whether you would conduct a structural equilibrium model or not. And for power analysis, basically, I believe that you can find any textbook about the SEM, and you can find the formula. But basically, there is an easy way you can calculate the sample size. Basically, you can use a Google, and also you type structural equilibrium modeling or SEM, power analysis, and then you will show a lot of website, and they will automatically to help you to calculate the sample size. And I think you can try this if you are interested. I won't show here in the PowerPoint, but I believe that you can do that from the Google websites. Okay, and also similar to a regression model, an additional statistic assumption is uncorrelated error term. It's similar to a regression model. Error terms are assumed uncorrelate with the other variable about the error terms. Okay. And the data, basically, structural equilibrium modeling required that our data should be at least interval. or ratio. Okay, that means that it should be a continuous variable. Particularly your DV, your dependent variable. Most as structural equation model, most textbook will tell you that if your dependent variable is category, or your observed variable as a dependent variable is category or ordinal, most textbook will say that they won't recommend you to conduct a structural equation modeling. Okay, that's a traditional textbook will tell you. But in the recent years, some alternative structural equation model, they developed several structural equation modeling models to help us to dealing with category variable, particularly dependent variable is a category variable or ordinal variables. For these details, you may refer to some textbook published in the recent 2 or 5 years. They will introduce about this kind of statistic analysis. But basically, currently, this based my experiences. If you want to publish a high-tier SSCI journal, most journals unwelcome your structural equation model, including a DV as a category or ordinal variable. There will be some papers published in a top-tier journal that DV is a category or ordinal variable. But this is not a dominant. This is not a popular. Okay. So for the detail about dealing with a dependent variable as a category in structural equation model, I highly recommend you can refer to some textbook. Okay. Here I want to touch about this because there will be a very complicated. There will be very complicated. Okay. So here I will give you a little bit introduction about the steps how to conduct structural equation modeling. Basically, many people, many researchers, or many initial learners, when they start structural equation modeling, they were very excited. They will try to use a SPSS or a SAS, just use a data-driven methods to find that whether the variable is correlated or not. If they found it correlated, and they will try to explore whether there will be the mediators, or they will try to use a structural equation modeling to test this kind of relationship between variables. Okay, we saw this is a data-driven, statistic-driven methods. Okay, but basically, in terms of structural equation modeling, the philosophy, it expects that a researcher can follow the theoretical driven research. What is a theoretical driven research? What's a data-driven research? Okay, data-driven research is much like data driving. It's much like a data mining technique. Okay, there is a data, and you explore whether there is an association between the variable. And then if you found the A and B, there is associations. And then you find the literature and try to report the A and B is significant in the publications. Okay, so we say this kind of research is more data-driven. Okay, and different from the data-driven research, there we call the theoretical-driven research. Okay, most social science research is theoretical-driven. What is a theoretical-driven research? Theoretical-driven research, we say this is highly strictly follow the evidence-based approach. The evidence-based approach, the most important, the spirit evidence-based approach for the research is that why we conduct the research, because the research is help us to resolve the argument in terms of the theory. That means that research help us to resolve the theoretical argument. So the theoretical driven research very focus on much about the theoretical debate. For example, how you build up these theoretical models. Okay, you build up this theoretical model should be based on theoretical inference, or should be based on the theories, okay? And this kind of theories, you want to use this kind of theory to explain some formula or some phenomena. And you need to logically to explain why you think this theory can explain to this phenomena. And you have to show that the strong logics elements in this inference. And then you, based on this kind of logic and based on this kind of theoretical argument, build up this kind of theoretical models. And then you collect the data. And to see the data support your argument or not. If you do this kind of procedure, we will say this will be a theoretical driven research. Okay, so the most important spirit in the theoretical driven research is that why we conduct the research, why we conduct the quantitative research, because we want to use the data to provide optional or additional support to our theoretical arguments. Okay, so structural equation model originally is developed from, or it is developed for theoretical driven research. So that means that when you want to conduct a structural equation model analysis, you need to build up your theoretical model logically. Okay, you need to follow the logic. You need to follow the theoretical arguments. You need to follow the previous theoretical perspective and theories to build up your models. And that means that the relationship between the relationship between variables in your model should be strictly logical. Okay, should be strictly logical. You cannot just cite some studies show that this relationship is significant, and so that's why you build out this model. It's not basically allowed in the structural equation modeling. You have to have a strong logically, a strong rationale to build out this structural equation model. And that means that you need to explain very detailed why this model and why this relationship between variables. You have to explain a very detailed. Okay, so before you conduct the structural equation modeling, try to use a theoretical driven research mind to build out a structural equation model. Okay, okay, so this is the first step. You need to build up a theoretical driven structural equation model. Okay, okay, and then you need to define the concept. You need to define the major variable in your models. Okay, and because why? Because if you have the strong definition, clear definition about your variables, and then you can start to find the measurement or try to develop your measurements. Why? Because the validity is very important. And an important element for the validity, measurement validity, is that your measurement should be consistent with your operational definitions. Okay, if your measurement is not consistent with your operation definition, that means that you will suffer about the validity issues. So here in the structural equation model, we also strictly require that researchers need to follow your operational definitions and to build up your measurement or to develop your measurement or to use the measurement the current that have. Okay, and also a structural equation model, if you have this kind of measurement and also a clear logic models, and then you can start to build up your structural model and the measurement model. Before you conduct the structural equation model, we basically require you to conduct a conformity factor analysis, CFA. In the structural equation model, it can help us to conduct a conformity factor analysis. And you can use the conformity factor analysis and to figure out your measurement validity. Okay, and if you finish the conformity factor analysis, and then you can go next and to try to build out your structural models. Okay, and it's very likely that a structural equilibrium model, particularly AMOS, it can help us to deal with the CFA and the structural equilibrium model. And CFA and structural model at the same time. So sometimes we seldom divide CFA and the structural model in the two different parts. We usually deal with in the same structural equilibrium model analysis. Okay, that's a beneficial about the structural equilibrium modeling. And if you have this kind of, if you have already built up your structural model and measurement model, and your CFA tell you that your measurement validity will be fine, and then you can go to the final step, that examining the structural model. Okay, when you examine the structural model, basically we have several index to help us to assess your model fit or not, or your model validity level. Okay, what is the model validity level? What's a model fit index? The model fit index tell us that your structural equilibrium model, your theoretical model, is consistent with our data or not. Okay, because this model, this theoretical model is built up by the logic, by the theoretical logics. Based on theoretical logics, you think that A will influence B, and then B will influence C. Okay, for example, if you, based on the theoretical logics or theoretical debate or theoretical perspectives, A should be lead to B and B should lead to C. And this is your theory. This is your theoretical model. But this kind of theoretical model may not apply to the data, may not apply to the people, the populations. So here, the model fit index is help us to assess how this kind of theoretical model fits to our data. Okay, so that's why we need to the model fix. Okay, so there are a lot of different model fix. Okay, for example, the common model fix here, we will use the chi-square. We will use GFI, and some people develop just a GFI that we call the AGFI. So we think they are the same family. GFI and AGFI is the same family. And there is a NFI, okay, and TLI, NNFI, and CFI, RMSEA, IFI, and RMR, and SRMR. So here, there's a common model fit index for the structural equilibrium modeling, okay? The most commonly used in the structural equilibrium model is that chi-square and GFI or CFI and RMSEA, okay? So this is the most common use. So for this kind of index, basically, we need to chi-square should be the p-value should be the smaller than should be the larger than the 0.05. Okay, that means that the chi-square tell us that assess the overall fit of discrepancy between the sample and fitted model. Okay, so if your chi-square, if your result tell you that chi-square value, the p-value is larger than the 0.05, that means that there is no differences between the model and the data. There's no differences between the significant difference between the model and data. Okay, and that means that your model applied to the data very well. Okay, but interestingly, chi-square is very sensitive to a sample size, and also structural equilibrium model basically require large sample size. So chi-square easily, the chi-square value easily to become very larger if you conduct a large sample size data. So sometimes we will forget the chi-square, this kind of value for our model fit index. Instead, if you use a large scale sample size, we will use the GFI, NFI, and CFI as alternative model fit index. Basically, we will require GFI, NFI, and CFI will larger than the 0.95, okay, 0.95. But some statistic book will tell you that larger than 0.90 will be okay. So basically, it depends on your judgment. Some researchers argue that GFI, NFI, CFI should be larger than 0.95. That will be the super fit. But some books say that at least 0.90 will be fine. Okay, so it depends on your research. It depends on your requirement. It depends on your sample size. And also another very important model fit index is the RMSEA. Okay, RMSEA is the full name is here. The rule mean square error of approximations. Okay, this is a very important index. The RMSEA should be below 0.05 or 0.06, but some text book will tell you that the liberal criteria is smaller than 0.05. Okay, so for me, I usually use a 0.06 as a criteria, and I usually use a 0.95 as a criteria. Sometimes I use a 0.90, but at least 0.90 is a basic requirement. Okay. So this is a model fit index, the common model fit index that we use in SEM. And the model fit index is help us to see, to assess how this theoretical model fit the data well. Okay, so this is a basic introduction to structural equilibrium modeling. I speak a lot, but you may ask me questions. Why you want to use a structural equilibrium modeling on Earth? What's beneficial to you? Okay. Basically, I will tell you from my perspective why I love a structural equilibrium model. Because there's a lot of beneficials to me or to my research. The first, simply speaking, I thought that a structural equilibrium model is extension of a regression model. Okay, but it is a better than regression model because structural equilibrium model can help us to consider measurement error. Remember that in the regression model, when you conduct a regression model, multiple regression or simple regressions, you can also deal with, there are a lot of IV predict the 1 dV, right? When you conduct the regression model, basically you sum each item in a scale. You make a summation of each item together into a scores and use this score to be representative of that variable scores. Okay, and then you calculate the different scale and then become the variables. You have a different variable in your IV and then predict your DV. In this kind of context, in this kind of situations, you are happy. You find that, oh, the IV1 have a significant relationship with the DV. The IV2 have a significant association with a DV. And you are very happy about the results. And then you report. Here, there will be another issues that you never consider. What kind of issue? Because in the regression model, basically, we assume that your measurement is perfect. Because in the traditional regression model, we never consider about the measurement error. That means that when we sum up all the each items together into scores to be representative of that variable. In this kind of situation, we assume that each item is a perfect measurement. They measure this kind of item or this variable 100% correct, no measurement error. So if you use the traditional regression model to conduct the research, that will be very dangerous because you never consider about the measurement error. The beneficial things in the structural equilibrium model is that we can consider measurement error in the structural equilibrium model. That means that you can use the structural equilibrium model to conduct the regression model, but additional benefit that we can at the same time control the measurement error for each item, for each variables. You can consider the measurement error into the model and to make your prediction more exact, more precise. And that's one of the very important benefits to the structural equilibrium model. And that's why I love the structural equilibrium model very much, because it can help us to figure out the measurement error. Okay? And the second thing is that a structural equilibrium model can deal with some path analysis, but different from the traditional path analysis, structural equilibrium model can be extension of the path analysis. Why I want to say this? Because the traditional path analysis, there will be the big issues. When you conduct the traditional path analysis, you need to conduct the different regression models. You may conduct a 2 or 3 regression model and to figure out the variable A and B, the regression coefficient, and also you have to conduct another regression model to understand the B and C regression coefficients. And then you have to combine this path analysis together. You use different mediation tests, okay, to figure out whether it's a mediation effect or not. It is great, but it will be very dangerous because when you conduct a traditional path analysis, you are easily to inflate the p-value. You are easy to inflate the significance level because you need to conduct 2 or 3 regression model to analyze this kind of path analysis. Okay, and the third thing is that I think there's a big plus and big benefits to structural equilibrium model is that it can be very helpful to us to deal with the mediation moderation model at the same time. In the structural equilibrium model, you can deal with the mediation model and also moderation model. Use the one-time examinations. So what's a mediation moderation model? For example, if you have a mediation model, we call the A lead to B and lead to C, and the C will be the mediation. If you want to use this kind of mediation model, will be fit to boys or fit to girls, or you want to know this model can explain girl population better than boys population or not, and you will deal with a mediation moderation model. And the structural equilibrium model is very good at this. You can deal with the mediation moderation model at the same model at the same time. Okay, that's why I love the structural equilibrium model very much, because it can help us to make our predictions more exact or more precise. Okay, here I just want to show you. I want to repeat this because traditional regression model our traditional regression model like this. Okay, you will calculate the items. You will sum the items together and to estimate the victimization. Okay, you will calculate each item in the parent support scale. Okay, calculate each item together, summation, sum them, and as scores to represent the parental support. And you sum up all the items in each scale, and then you got different IV scores, and you predict your dependent variable. Okay, this is a traditional regressions. And just as what I say, here in the traditional regression model, you forgot to estimate the measurement error. You in the traditional regression model, you consider each variable scores should be the perfect. The scores, the measurement error should be the 0, should be the perfect. Okay, and here, I show you another. This is a figure. This is a structural equilibrium model can deal with about such a mediation model. Okay. Traditionally, this model we can use the path analysis to get the results. But if you use the path analysis, you may conduct a 2 or 3 regression model. For example, you need to conduct the regression model for this one. Okay. And also, you need to conduct regression model for this one. And you also conduct additional regression model for this one. And you also conduct additional regression model for this one. And then you will get the regression coefficients from each regression models. And then you may use the Sobel test to test a mediation effect. That will be okay. That is the way a traditional path analysis conduct. But the issue is that you conduct this, the one regression model, and this is second regression model, third regression model, and fourth regression model. And that means that you need to conduct a full regression model to get the regression coefficient of each path. And the full regression model will lead to inflate the p-value. For example, this regression model, the p-value will be the significant level will be the 0.05, okay? And this will significant level will 0.05, 0.05, 0.05. So when you finish when you get a result of all the regression coefficient from this path model, you will basically your significant level will 0.05 times 4. That will be 0.05 times 4. That will be a 0.20. Okay, that will be the significant level will be inflated. That will be that you are more likely to suffer from the type 1 error or type 2 error. Okay, such like the way. Okay, but is there any way that we can use a model to conduct or to get the regression coefficient use the one time? Is there any way we can do that? Yes, basically yes. We can use the structural equilibrium model. You can use one time to get the regression coefficients here, and also at the same time calculate the mediation effect. Okay, that's why I love the structural equilibrium model very much. Okay, there are a lot of different softwares. To deal with to conduct structural equilibrium modeling. We use the AMOS, EQS, Smart PLS. We use the R language. M+ is also another powerful software to deal with the structural equilibrium model. And there are a lot of different software, new software to deal with structural equilibrium modeling. If you are interested, you can try to find out this kind of software and how to operate a structural equilibrium model. Today, I will focus on the AMOS. Okay, why I introduce AMOS? Why I use AMOS more often than other software? Because the first one thing is that AMOS basically is part of SPSS. Okay, that's a major reason. Our university, many universities, they buy the SPSS in addition to AMOS. They buy together. That will be the cheaper. Okay, so basically, most university they buy SPSS in addition AMOS together, and that's why I use one of the major reasons we use AMOS. And another reason is that Amos is easy to learn and operate. It's very friendly. You don't need to understand a program language. You just simply draw the figures, the drawing models in the Amos, and then you will get the results. And their computations is very quickly. Okay, the computation is very quickly. Okay, you don't have to use a lot of program language to deal with your variable relationships. Okay, and also you can easily to identify the results from the graphical and non-graphical applications. Okay, and also a very powerful thing is that you can see the figures, you can see the graphical in the Amos, and to understand your model results and to explain the model very well. Okay, that's why I want to use Amos. Okay, so here I understand that maybe you don't understand Amos very well, but no worry. I will show you some example. Today I prepared the three examples to demonstrate how we operate Amos. And through this kind of demonstration, I believe that you will know why Amos is so powerful or so popular for many initial learners for structural equation model. Okay, so here I would like to introduce my first example. Okay. Okay. Here, before I introduce this example, I would like to let you know this sample, this data is already published. Okay. This is an article that I published in the School of Mental Health. This article's the model is here. Just briefly to show you this model. Okay, just what I say before you build up a structural equilibrium model, or if you conduct a structural equilibrium model, you need to build up a very logical, theoretical driven models. Okay. So here, the same way I follow the spirit of structural equilibrium model. I build up this model. Okay, this model is highly based on the theoretical debate or theoretical argument or logic from the previous theories. Okay, why I want to have this model? Okay, this model is dealing with about the association between the family climate, teacher-child relationship, and peer relationship, and school bullying victimization. Okay, and you will find that most of my example today will focus on the school bullying and also adolescent mental health, because this is my research area. Okay. So why I want to have this model? Why I want to examine this model? Okay, I will briefly to let you know. Okay, the first reason is that traditionally, all the theories, all the theoretical perspective, I believe that you always have this such belief. We always argue that the family climate or family function, the children who live in a bad or poor family climate, that means that if the children's parents, they argue, they have a family violence together. They have family violence every day. They have a conflict every day. And if these children develop in this kind of family, they are more likely to be bullied in school. Okay, I believe that most of you believe this. And indeed, many theoreticals, many theories, they always believe that the family functions, how the children's family climate will influence the children's chance to be bullied in school. Okay. So they argue that the family climate and school bullying victimization, this kind of relationship is direct. And this relationship is causal effect relationship. They believe that the poor family conflict will increase the children's chance to be bullied in school. But interestingly, when I look for the literature, I found that not all the empirical study or observational studies support this kind of argument. That means that most observational studies or empirical study found that the direct relationship between the family conflict and school bullying victimization is non-significant. Only some studies show this relationship is significant, but this association, most of them are very weak. This is surprising. This is surprising because traditionally we believe that how the family will influence school victimization. We have this kind of strong belief for over 20 years. But very interesting, the empirical data did not support this kind of argument. So the next step, I asked the question, why? Why we still find that in the clinical case, when we find the school victims, when we find a student victims, we also can find that their families seems like a little bit problems, a little bit issues. We also can find a student victims. When we interview with them, we can still find that their family, their parents, a little bit, their parents argue or conflict often, very often. So why? But in the studies, the empirical study, it did not show this the direct link. Why? I asked the question, why? Finally, I found a theory argue this kind of association. They argue that the family climate is not direct impact to school bullying victimization. Instead, they argue that there should be the psychosocial mechanism to influencing the association between the family conflict and the school bullying victimization. Okay, and this theory I also cite in this article. If you are interested, you can look at the theories that I argue in the literature. And in these articles, I don't want to illustrate very detailed, but you can see that when I write a structural equilibrium modeling article, I follow the traditional structural equilibrium model spirit. I need to step by step to have a logic to build up my theory. Okay, so this kind of so the theoretic the previous theory argued that there should be a psychosocial mechanism between there should be the psychosocial mechanism influencing the relationship between the family climate and school victimization. And there another theory, they support this kind of theoretical argument, and they further address that the school social relationship is a very important psychosocial mediating mechanism between the family climate and school bully victimizations. Okay, this theory we call the school contextual theory. School contextual theory argue that why students have experienced school victimization, because they argue that school factor, particularly school social relationship, is a very important mediator between the family factors and the school bullying. So I follow this kind of framework to build up this kind of theoretical models. And interestingly, the school contextual theory, this kind of model, there's a very little empirical study to provide a support to this kind of argument. And this is why I want to have this kind of model and to examine this model using my data in Taiwan. Okay, so here, first step, I need to logically to develop the structural equilibrium model. How I logically develop this kind of structural model, you can refer to this kind of article. I want to illustrate more detail. Okay, so now I build up this kind of model. So I have no idea whether this kind of theoretical model can apply to our data or not. That means that I'm not sure this kind of model built up by logics can be consistent with our population or not. So later, I build up. So later, I start build up. So later, I build up a structural equilibrium model here. Okay. You see this one? Okay, sorry. Did you see the AMOS here? Okay. Okay, see, so this one here, the model in the AMOS, this is the model that I build up, okay? You see the article, the model here, I applied this theoretical model in the AMOS. This is all AMOS software, okay? Here you can see that the family means that family climate. The teacher means that teacher-student association. Here, this is a peer. Peer means the peer association or peer quality, okay? And here, victimization is called a school victimization, okay? So here, I just briefly to let you know, this is a model, okay? This is a model that I build up in the articles. And then I can, when I build out this kind of a model, I can use analysis to calculate. Don't worry, I just demonstrate quickly that, and later I will show you how to step by step to build up this AMOS model, okay? So if I build out this kind of model, I can click analysis and they will help you to calculate. They will help me to calculate this kind of model. And then I can get the report, okay? So here you can see that this is the AMOS. This is AMOS. You can see that how powerful AMOS. AMOS, there is no program language. There's no program language. You just show this kind of, kind of figures in the AMOS, and then draw the line, draw a direct line, and draw the correlations, and put items here, and then you have a measurement errors, and then you can use this kind of figures in the AMOS, and then catch the data, and then click analysis, calculate estimate, and then you will find the results. You will find the result. And you can find the result, just use a very, you just click here, and you can get a standard estimate. And here you can show, and AMOS will show you the standard regression coefficient here. Okay. Okay. But sometimes you don't have to go back to see another report to see the regression coefficients. You don't have to. You just use the AMOS, this kind of software. You can easily to identify the regression coefficient here. And you can also easily to identify the factor loading here. See how powerful it is. Okay. And also, if you want to look for the detail, if you look for the detail, you can plus the view text icon. The view text icon will lead you another output. In this output, you can see the more detail about your model. For example, I can put here note and the model, and it will show you that the summary of the model. It will tell you that the model, the degree of freedom is like this, 84. And the chi-square is this. The chi-square value is this here. And also, it will let you know the regression coefficient here. This is the table, regression weight table. And the regression weight table is also will let you know this kind of path. For example, family to teacher, family climate to teacher relationship with the teacher. This kind of path, okay, is a significant or not. It will tell you the p-value. 3-star means that. 3-star means that the p-value, the regression coefficient for the p-value is smaller than 0.001. Okay, here it will tell you that okay, sorry. Okay. I'm not sure why here. Okay, hold on a second. Do you see the output, right? Okay. So here you can find that p-value here. This is do you see the output? Because okay, you can see output. Okay, so you see output. This 3 star means that the p-value is smaller than 0.001. Okay, if the p-value, if the path, the regression path for the p-value is greater than the 0.001, and they will show you the exact p-value. For example, the path for association between relationship with the teacher and school victimizations. The p-value is a 0.01. Okay, so it will show you if your p-value is greater than 0.001. Okay, here it shows you the p-value is greater than 0.05. That means that the path is not significant here. That means that the family climate to the victimization, this kind of path is not significant. Okay, so here it can show you the output can show you the regression coefficient and also the p-value, and here it will show you the standardized. Okay, this estimate is not standardized. Okay, and here you can show you the output can show you the standardized regression weights for each path. Okay, and also another powerful thing is that the output will show you the model fit. Okay, you can see that NFI, IFI, CFI, that's a common use. That's a common use in structural equilibrium modeling is greater than 0.90. Okay, NFI, IFI, and CFI is greater than the 0.90s. So that means that the model basically fit the theoretical model well. Okay, acceptable. It's acceptable. And another model fit is RMSEA. Okay, basically I use the criteria is that RMSEA should be smaller than a 0.06. Okay, 0.057 is smaller than 0.06. So RMSEA is approved. So that means that the data basically is okay, is acceptable. That means that our theoretical model basically fit the data very well. Okay, so now here I just show you that the very basic. Sorry, okay. Here I just show you the basic, the very basic AMOS looks like. Okay. So now, next, you may ask me a question: how you build up this model? How you build up this model in AMOS? Okay. So now, I will give you a demonstration how I get this kind of structural equilibrium modeling. Okay. Okay. So now, here is a new, very new platform. Here, I would like to try to build up the SEM model in AMOS, and I want to show you how I build up this model. Okay, so here AMOS is very friendly. They provide the icons here. The icon is very important. It's very, very important because it can help easily to draw this kind of figures to our models. Okay. So how I build up? Basically, for example, I will first build up the latent variable. We have 4 latent variable in the model that I show you. The first latent variable we call the family climate, right? The second latent variable is the relationship with the teachers. The third variable is the third latent variable is the relation with peers, and the dependent variable is the school victimization. So I have a 4 latent variable here. So here I can click this icon, and I can draw the latent variable here. The atlas means that the latent variable that I intend to draw. Okay, I draw this one, and I can adjust. I can use click the right on your mouse, the right click, and then you can adjust the figure shape of the object. If you don't like this kind of figures, you want to be a kind of circle, feel free. Okay. If you want to ellipse, you like ellipse more, you can do it this way. If you want to the latent variable bigger, sure, no problem, you can do that. Okay. So here, this is some function in Amos, you can do that. But basically, I don't want to the latent variable, the ellipse is so large. So this is the model I like very much. Maybe I can put a smaller here, okay? And then when I finish this kind of latent variable and I feel this kind of shape is very great. I love the shape very well. And then you can click, you can have the right click on your mouse, and you can click the duplicate, and then you can duplicate your latent variable in this model. Okay, there is a dependent variable model. We have a full latent variable here, so you can duplicate this kind of ellipse here. Okay. Here, you found that this latent variable is too close to center. You want to move this kind of latent variable left, a little bit left. Sure, you can right click, and then you can click move, and you can move this kind of latent variable. Okay, you can adjust the latent variable here, and you can make the figures are more beautiful if you want. Okay, so now I finished the latent variable here. Okay, if you have a latent variable names, you can type this. So you can right click here on the latent variable, click this function, object properties, and click this. And you can insert the latent variable name. For example, this latent variable name is a family climate, and I will use a family climate here to name this latent variable. And also here, this is a relationship with the teachers. I put down the teachers here, okay, or teacher-child relationship, or teacher, sorry, T-A-C-H-E-R, sorry, T-H-E-R. Okay, teacher, child relationship. I can insert the variable name here. And again, here, I can insert the peer relationship. I will use the peer relation, okay? And again, here I can click the object properties, and also I can click the school, and name it the school victimization. Okay. Okay. So you finish the name the latent variable. Okay. So next, we need to build up. We need to try to build up the measurement model. Before we start the build up measurement model, very interesting. There is an icon in structure in Amos that can help you to build up the measurement model. Okay. In the family climate, this scale have 6 items. So I can press this icon here and move to the latent variable, and I use the left click, and click 1 time, 2nd time, 3rd time, 4th time, 6th time. Okay, 5th time and 6th time. Okay, and then it helps us to build up the measurement here. Okay, so I want to show you again. I can show you again. Okay, here you can have this one. Okay, icon, and use a left click 1 time, 2nd time, 3rd time, 4th time, 5th time, and 6th time. Okay, and then they will help you to build up this kind of measurement items. Okay, and then if you feel that this is overlap, you can adjust the measurements items. Okay, how you adjust? Again, click the right, have a right click, and there will be a function called rotate. So click rotate and left to right. And have a left click, and you can rotate this items and also measurement area to another directions. Okay, similar way. Okay, here teacher-child relationship. I remember I have a 3 variable here. Sorry, 3 items here, and I click here. And peer relationship, I have a 3 item here. And school victimization, I have 3 item here. So again, I can adjust the figures. So I use a rotate. Okay. If you want to rotate here, that will be fine. If you want to rotate here, will be fine. Okay, either direction you want. Okay, either direction you want. Okay. If you think this is more beautiful, that will be fine too. Okay. So now we try to initiate the measurement model here. So this is observed variable. This is a measurement error. Okay, this is a measurement error. This is a latent variable. Okay, next I will deal with the structure path again. Okay, so here, base my model, base my theory. There is a 1 error. Okay, there is a direct effect here. Okay, okay. Theoretical assumption there will be direct effect here. So I can have this icon, and I can put a single error here from the family climate to school victimization. Okay. And next step, I also have the assumption, the path here, family climate to teacher-child relationship. I put the single error here. And here, definitely also I have this here. Okay. I also have the direct effect here. I also have the direct effect here. And then I can finish the structure model. Okay. And also in structure, in AMOS, one thing very be careful is that in AMOS, this is a default. All the dependent variable in the AMOS, you need to set up the deviance or the dependent variable error. We often call this as deviance or dependent variable error. Okay, you need to have this one. Okay, you need to have this one here. Okay, this one you just can put this icon, and you put on the dependent variable. It's automatically to have set up for you. Okay. Again, I found this is very complicated figures. I want to rotate it, or I want to rotate this. Okay, I want to rotate this. I want to rotate this. Okay, and I found this is overlap, and I also have a right click. I have a shape object. I want to become a smaller. Is that okay? Yes, definitely it will be okay. Okay, okay, and there won't be an overlap with the observed variable. Okay, so now I finished build up the structural model, and here remember in the theoretical models, in the theoretical argument, there should be the correlation. These 2 variables should be the correlation. So I have the double arrow here, and then I found this is very complicated. I want to move this correlation outside the figures. Is that okay? Sure, definitely will be okay. Okay, so now I finished the structural model here. And then I have put on the measurement items in my observed variable and also measurement error. How I do that? Very interesting. You can do this way. Basically, you can have first of all, we have to catch the SPSS data because AMOS is connected to the SPSS data. So we need to use the file functions. There is a data file to find our data in our computer. Okay, so here I use let's see. Okay. So this is the data that I have here. This is the data I have here. Okay, this is the data I have here. Okay, so I put the data here. I select this data as my analysis data for the AMOS. So I just use this, click open. Here, AMOS will show you that you catch the data. That means that the AMOS consider this the data is a major analysis data form, major analysis platform, okay, data platform to your AMOS software, okay. So then I click OK. I click OK. Here, this data have a sample size is over 1,200, and here I can click OK. When I click OK, that means that AMOS software already catch your SPSS data as a major platform for the analysis, okay? And then I can use another functions. I can use another function is that called a view here. The view here, I can find the variable in the data set. When I click the variable in the data set, and it show you that your SPSS data that you catch, you will from the data you catch, they will give you the list of the variable names in your SPSS and also label in your SPSS. Okay. And then this is very helpful to me. Why? Because I can use this kind of functions to draw this kind of variable name into observed variables and to build up our measurement model. For example, for the family climate, I have 6 items to measure family climates. The first item is a family, the variable name is a family care. This item asks the question, there are people in my family who care about me. I use the Likert scale from the 1 strongly disagree to 5 strongly agree, okay? So here, I can see the variable name here and also the item, the measurement item that I exactly ask. And then I can pull this item into this observed variable. And you can see that there is a word here. That means that you successfully to pull the data in SPSS in our measurement model, the first items, okay? And again, the second item I asked a question about the family climate is a family health problem. The variable name is family health problems. I asked a question if I have a problem, people in my family will help me or not. Again, I use the Likert scale, and then I can pull the variable here. Again, I pull the third variable here, fourth, and also fifth, and sixth here. Okay. Same with other latent variables. I also can put here peer relationship items. The first item is whether my friends are usually nice to me or not. Again, use the Likert scale. Here, parents, my friends get along with me well together or not. And friends support here. I can put the item here. That means that the data already, AMOS, it help you to consider the data information into the AMOS model. Okay. Again, here, teachers, we have the 3 items to measure teachers-child relationship. I can put here. And again, I have 3 items to measure school victimization. They are whether you were being hit by other children and called unkind name by other children and also left out by other children in your class. Okay, here I already pull out. I will already pull the observed variable into the measurement model. Here you will find that the figures seems like a very complicated, a lot of words here. Okay, if you want to reduce the words, again, you can have each observed variable. You can click object properties, and here I can leave the variable name here, delete a variable label here could reduce the words. Is that okay? Sure, definitely. But you cannot delete a variable name. If you delete a variable name, the MOS cannot recognize this observed variable is which one. Okay, so you can delete a variable label here, and to make your figures looks clear. Okay, so I can delete this. Delete this. Okay, delete this. Okay, delete this. Okay, delete this. Okay, I want to because time issue, I don't want to delete all of them. But you can do yourself. Okay, and now the rest of the thing is that we still have the measurement error. We don't have the put estimate in our measurement errors. Okay, this is the measurement errors. So we can insert the measurement error by our hand. For example, object properties. We usually insert the measurement error is E1. This means the measurement error 1. You can by hand measurement error 2. Okay, and again 3, 4, 5, 6. But this is a too waste of time. Okay, in MOS, it can help us to easily to fill out this kind of measurement error. Okay, here's we have a plugin functions, and plugin functions there will be a function. It's called the name observe name observe variable. So you can click name observe variable, and here MOS will automatically to help you to insert the measurement error. Okay, the measurement error. So you can see that they insert the measurement error here. Maybe this is too much. I try to delete it, and you can see that. Okay, you can see that. Okay, okay. See, you have a measurement error for each measurement error. Okay, here this is observed variable. But this is not measurement error. This is dependent variable deviance. So we give another name to distinguish. This is deviance for dependent variable. I use a deviance at D1 here to make the pictures models more clear. So I use a D2, D3. Sorry, this should be a D2. Okay, D2. Okay, so now I finish the build up the structural equation model in MOS. Okay, see, you can see that it's very friendly. It's very easy to handle. Okay, you don't have to write a program language, and then we build up the SEM model in MOS. Okay, so now after we finish the build out SEM MOS, we build out a model in the MOS. And then next, we will go to the analysis, okay? But here, before you conduct analysis, we need to deal with several minor things. For example, we need to deal with missing data, okay? How we deal with that? You can go to the view here. There is analysis properties. Click analysis properties. And then you can show you that how you estimate. You can the MO show you how you estimate the model. Okay, basically we use a maximum likelihood to estimate the model. Okay, it's the default. MOS has a default maximum likelihood because this is a common way to estimate a structural equation model in MOS. Okay, here there is another function we call the estimate means and intercept. Please click this. Why we need to click this? Because if you click this, that means that in the MOS, they automatically to help you to deal with the missing value. Okay, they use the means and intercept to help you to replace your to estimate your missing data in MOS models. Okay, so you have to click this. Okay, and then you can go to the output. Here, there's a function go to output. The output that you choose that what kinds of output that you would like to addition in your output, addition element in your output. Okay, basically output will show you the model fit, chi-square, and regression coefficient. That's a basic output. If you want to additional, you can have click this. For example, you want to know the indirect or direct effects. You want to the standardized estimate, you can put here. And you want to R-square, you can put here. And if you want to the factor scores, weights, you also can put here. So here, this is a function that you just click it, which one you want, and then you finish. Okay, so we close it, and then I can go to the analysis. And next, I just go to the analysis functions and to click the calculate estimate. Click okay, and then output. This is an example. So I will say the test. Okay, so test here. I save the files, and now you can see that Amos already calculates. Okay, the name variable is invalid. Okay, so it told me that my variable is not okay. Basically, they don't like this kind of way. Okay, relationship. Okay, school return. They don't like a space. Okay, basically, when you name the latent variable, Amos don't like space. Okay, so I put here analysis. So see, finish. You want to see again? I put analysis and calculate. See here, they calculate and then finish. Okay, you can write. See again, you can see the right bottom corner. Okay, I click the again, and you can see there is a calculation here, right? Okay, so they finish calculation. Okay, when they finish calculation, you can easily to use this kind of function. I will use the view output path diagram, and then I can choose the standardized estimate, and it show you that the standardized coefficient here. From this figure, you can see that R-square for this model is 0.15. That means that this model contributing to the 15% of the variance to the school victimization. Okay, and this model consider the measurement error. Consider the measurement error in the model. Okay, and you can see that there is the regression coefficient here. You can see that family climate has an almost zero a regression coefficient to school victimization. That means what? That means that traditionally we believe this is the link. This kind of belief should be corrected. Okay, in our model, the relationship is very low. The strength is very low. Okay, the regression coefficient is very strong from the family climate to student-teacher relationship, and also strong to a student-peer relationship. And you can see that the relationship between the peer relationship, school victimization is very strong too, but this is a little bit lower from teacher-child relationship to school victimization. Okay, another benefit that in this model you can see the factor loading at the same time. Okay, you can see the factor loading here. The factor loading, basically the factor loading is another it's not a symbol. It's another meaning. Showing that the measurement, the item validity is good or not. Basically, in social science, we require the factor loading should be at least 0.70. But I understand in public health or in the medical journals, sometimes they just require at least a 0.40. But in the social science journal, most of them, they require at least the factor loading should be a 0.70 or at least 0.60, and that will be no issues. Okay, so here for the social science area, we found that the factor loading here, this item is pretty low. It's a 0.45. That means that the validity of this item is not very good from the social science perspective. Okay, and you can see that here the school victimizations, that there is a point 53. This is not good measurement here from the social science area, because this vector loading is below the 0.70. Okay, so here I want to tell you that is another benefit AMOS is that it can help us. It can help us to identify easily to whether each item has a good vector, have a good validity, measurement validity or not. Okay, so for example, in the social science, when we found that this item is pretty low, is a 0.45, we hate this. This means that this measurement is the validity is pretty low because we need to meet the criteria about the 0.70. So I found this factor, this such a vector loading, such a measurement validity, low measurement validity will impact our research validity. Okay, will bias our research results. So how I can do in the practical, we can try to delete this poor measurement. How to delete? I can use the erase object here. And here I just can delete. And then reanalysis. Okay, reanalysis. And here, AMOS will show you another results. Will show you another results. Okay, and they will show you another new model fit for this model. Okay, when you delete this, and you also found that, oh, this vector loading is pretty low. This is very low, okay? But this is a very, very low because it's 0.49. It's crazy low. Basically, when I submit a social science journal, it definitely will be rejected, okay? So here, I can delete this one, okay? Delete this one and run an analysis. Okay, I can delete one, run analysis, okay? Okay, and you can see the regression coefficient again here in the model, okay? And you can see that regression coefficient a little bit changed here, okay? The R-square still keep the same, but these things like a model will be much better fit, okay? For the detail, you can view the text here. You can view the text here, okay? Text here, you can see the model fits. You can see the model fit. All the model fit is much better, right? NFI, RFI, RFI, TLI, CFI, all much greater than the 0.90. And particularly NFI, IFI, TLI, CFI is greater than the 0.95. And let's see the RMSEA reduce a lot, okay? Basically, it should be smaller than the 0.06. Now is far below 0.06. And then you can see the estimate here. Okay, you can see estimate here. It shows you that, very interesting, family climate, the coefficient from family climate to school victimization is not significant. This is consistent to a previous study, but different from the theoretical predictions. Okay, so here, this is, I want to basically show you how we operate structural equation modeling here. And I hope that you can understand how we operate this SCM in the example one. Another very important technique I may introduce here is that, for example, this is the test that we use, right? Now, for the things, I would like to do one thing is that here, this is a model. This model is for all children, for all Taiwanese children, that the data I collect. This data is a random sample that I collect in Taiwan. This is a grade 3 in elementary school. I collect over 2,000, I forgot, 2,000, maybe 2,000 sample size, okay? But now in this sample, I have male students and also female students, right? So some people, some theory may argue that, oh, this model may be better explain girls or better explain for boys. Why? Because boys definitely have a high level of school victimization. right? Because boys usually have a poor student-teacher relationship than girls. Because boys have a very poor social skill with their relationship, so their relationship with the peers will be very low. And the boys, they don't like to talk with their parents, so the family climate may be lower than maybe lower than girls among the male students. So some people argue that this model may be explained better for girls and explain poor than is poor in boy students. Okay, that means that some theory argue that this kind of model may be moderate by gender. Okay, and some theory argue that this model only can explain girls or only can explain boys, but cannot explain the other gender. Is that really true? We don't know. So we can conduct a mediation moderation model in the AMOS. Okay, how we do that? If you involve this mediation moderation model, we can use the AMOS to conduct this. For example, here, I will here analysis, I will manage group. I will create a first group is boys, and the second group is girls. Okay, here, not close. Here you can see the boys and the girls, right? And here I go to the data, and you can see that data. I will show you the boys data and girls data, and you can try to you can go back to the file, catch the SPSS data that you have. Here, okay, I catch the data here, okay, and then here there is a function. The function is that group variable, right? There is a gender. I put the group variable here, gender, and number one, label one, variable one is the boy, okay, and here I can define the gender variables. Here, number two is the girls, okay? So our AMOS can, based on your data you provide, and to catch the boys data and girls data, okay? So I click OK. So here, AMOS will read your data, and you give an order to AMOS that one in your SPSS, the gender variable, the one is boy and two is girls, okay? And then you can conduct analysis, okay? You can conduct analysis. When you conduct analysis, and you can gather result here, okay? And you can see the boy models, regression coefficients. You can see the girls model regression coefficients. And you can, from the report, you can get the boy and girls model fits. For example, you can get an estimate about the boys and girls. Here, this function, you want to see the girls, you can put the girls here. If you want a boys, if you want boys, you can put here. If you want a girls, you can put here, and they will show you the output is the boys results and girls results. Okay, and another thing is that if you want to see this data is the gender can be moderate this data or not, you can doing a mediation moderation model at the same time. Usually, how can do that? We can set, we can fix, or we can constrain the model. We can constrain each path. Okay, we can constrain each path together at the same time. If I constrain this, I can constrain this. I can just put here and use the P4, P5, and means that I constrain the path. Okay, what means that I constrain the path? I constrain path is that I order AMOS to assume that this path is equal. Okay, is equal between males and the females, and I will examine that under the equal constraint there is a differences between the genders or not. Okay, and then I can use a calculate estimate this is a constraint model, and then constraint model, I can write down the model chi-square. The model chi-square is, let me write down. The model chi-square is 267.8 degree freedom and 1, 2, 3. Okay, this is a constraint model. Okay, but now because I want to know the gender can moderate this model or not. So now the next step, I release all constraint model. I release that constraint model. Okay. I release all constraint model. Okay, I release all constraint model. I run again. Okay, when I run again, I will get the chi-square value. The chi-square value this time on constraint model will be is the 2546. The degree freedom is 118. Okay, now how we know the gender can be moderate this model or not? We can calculate the differences between the chi-square change and degree freedom change, and we got a ratio, and we call this is a ratio of chi-square change and degree freedom change. Okay, so now we can calculate that chi-square change is 267.8 minus 254.6, and divide chi-square change will be 5. Okay, and we got a ratio. We got a ratio, and then we check the chi-square table. And when we check the chi-square table, we found that this is not significant. What do you mean? It means that when we constrain the model, that means that when we set each path is equally between male and female, this kind of model, and the model we set up the path free. That means the unconstrained model. This kind of two model, there is no differences, and this means that there is no gender differences in this model. That means that the gender cannot moderate this model, and that means that the model apply to explain male and female student equally. Okay. So here I want to show you that maybe this is very complicated, but at least I want to show you that we can conduct the gender comparison, or we can conduct a mediation moderation model. Another case is that if in your model, your hypothesis that this path, only this path, there is a gender differences. Again, you can use the same way. You can constrain this path and release this path only to see the chi-square change and to figure out there is a gender differences in terms of this path. Okay, this is why MOS is so powerful. Okay, so here now I show you the first example. I understand we don't have enough time, but don't worry. The example one, I also almost show you all the things. Okay, and actually there is an example two. The example two, I don't think I have enough time to deal with this, but I will show you. I will simply show you. I won't go step by step. I want to show you how we deal with mediation effect. Okay, so share. Okay. This is another model. Originally, I want to show you, but here, basically, we can use the same way. I can calculate the regression coefficient for each one, right? For each path, right? I can calculate path each one, right? Okay. But now I would like to know the indirect effect. For example, I would like to know this indirect effect. through the child depression. Okay, I want to know the indirect effect here. How I calculate, how I conduct in the AMOS. Basically, we have this one. We have this kind of techniques. Here I want to show you here value. Here and then we have analysis properties. Analysis property is the bootstrap. In AMOS, we use the bootstrap technique to estimate indirect effect or mediation effect. Okay, so here we have a function here is bootstrapped, and you can click this and this, and this one is that how many sample how the number of bootstrap sample you want to collect, you want to analysis. Okay, basically I will use how about I use 2000. Okay, here this is a confidence basic confidence level. It's a bootstrap confidence level. Basically we use set up 90, and that means that p-value will be a 0.01. But I usually have a more mean. I usually set out a p-value is a 0.05. So I put here 95 here, a confidence level here, and then I cross it, and then I catch the data. Okay, I try to catch the data. Okay. Oh, I found the data here. Oh, okay. Let me see. Example 2. Example 2 here. Okay. I have a data here. Okay. I get the data. This is the data for this model, and I choose this data, and then I have an analysis. I can calculate. I'm sorry about this. Okay. Again, they hate AMOS. Generally, they hate the space. Okay. They hate the space between words. So I have here. Okay, I adjust this model here. Victimization. Treatment by teachers. Not okay. Okay. Here. And then I analysis again. Okay. Okay, they're calculating now. Okay, they finished calculating. Okay, finish the estimate. And then I can go to the outputs. I press outputs. Okay. Okay, here. Okay, basically, the original model will give you the regression coefficient. But the regression coefficient, they just give you the regression coefficient. But you have no idea what's the indirect effect. Okay, you have no idea what's indirect effect. Some people will tell you that, how about calculate this one, how about this one times this one, and you got indirect effect. That's totally wrong. Because why? Because in this model, we consider the measurement error. So here, how we calculate the indirect effect, just what I say. I use that way I show you. And here, you can find the output here. The output here, we use the bootstrap. And there you can see the estimates. And the estimate, this is a scalar, and this is a matrix. Okay. The matrix here, there will be the total effect, direct effect, indirect effect. Okay. There is a standardized indirect effect. I usually click the standardized indirect effect. And here, there's another function we call the bootstrap confidence. Okay. Here you can calculate. You can find a model here. Okay, you can find a model here. There it show you that the standardized indirect effect. Okay, you can find that the parental depressions through our mediator to our dependent variable. Dependent variable is that male treatment victimization by teacher. Okay, you can find that the IV through our mediator to our DV, the standardized indirect effect is a 0.056. Okay, okay. And then you can find this. This is significant or not? It shows you that two-tailed significance here. Okay. Here, I just quick show you that basically in a SEM model, in the MOS, we can use the bootstrap functions to calculate the indirect effect, okay? The final model I want to show you, I'll give you okay, I understand now, I'll give you a 1 minute. Sorry, okay, let me, I try to, I'm sorry, I did not control the time very well. Okay, here I just give quick, let you know. Basically, MOS also we can use the MOS to conduct longitudinal data, okay? Here I show you. Sure. Share with you. Okay, here, this is the example that I want to tell you. Basically, as MOS can deal with the longitudinal data. This is a two-way longitudinal data. I use a cross-leg model. Okay, cross-leg model allow us to estimate the causal effect relationship between the variable. Okay, so here, this is a type 1. This is a type 2. This is a panel data. And this is a cross-leg effect. It's a cross-leg effect. Okay, so here again, you can conduct the cross-leg models, longitudinal models in MOS. And you also can conduct a latent growth curve in the MOS models. So, but today, because of time issue, I have no time to show you that how we conduct the latent growth curve model. And here, I hope that the brief introduction to MOS will let you understand the MOS more. And I hope that you can start to be interested in conducting a structural equilibrium model using MOS. Here, I just want to tell you that learning MOS is very easy, okay? You don't have to spend a lot of time. You just use about 1 week or sometimes 2 or 3 days, and you can operate MOS very well. And if you want to use the structural equilibrium model, but you are very confused other software, if you feel very complicated in other software such as M+, if you hate program language, and MOS is the right one that you can choose, okay? And it's easy to learn, and you can make analysis quickly than other software, okay? I hope that you like my introduction today. I'm sorry, maybe I didn't cover all of them, but I hope that you can start to interesting about the MOS. And thank you very much. And any questions?
We thank Dr. Chen for giving us this very, I would say this very detailed and comprehensive briefing of the structural equation modeling. Okay, it seems that that's not enough time. There are too many things in the SEM. But I think Dr. Chen has covered some basic information and also some advanced models in the structural equation modeling. Of course, if the students want to have more knowledge, I think we have to do more work, like consult Dr. Chen by the email or something like that. Okay.
Definitely welcome. Yeah.
Yes. Because of the time, so I think I will open the most 2 to 3 questions. Okay. May I know if there's any questions that the audience wants to ask? I think that the students maybe are still digesting, and also maybe noontime, so become a little bit hungry. I have a question. Is that you mentioned about the mediation moderated models, but it seems that in your moderated models you only use the category variable. So have you ever tried to use the continuous variables in your mediation moderated models?
Yeah, basically, no. This basically latent variable. I use the observed variable is ordinal, but basically the if you have at least 3 ordinal label items and then combine the latent variable, and basically SCM will treat it as a continuous variable. So basically, in the model that I just demonstrate is that can be treated as a continuous variable for each latent variable. However, this is really a big issue. There is a lot of debate whether we can use a category variable in SCM models. A lot of scholars, they provide a different perspective. Particularly our dependent variable, some scholars mentioned that we cannot use a category variable in our dependent variable as a category variable. So for this kind of debate, there is I think they keep it very long. But for my perspective, I definitely avoid a category variable in my structural equation model, and also happily in my research area, basically we seldom deal with a category model, because in school bullying area, if you have a category variable in your model, sometimes the journal will consider this is not good paper. This is external validity will highly influence, and they may reject your paper. So in my experiences, I seldom use a category variable. I seldom meet a situation that I have to deal with a category variable in a structural equilibrium model. But I understand in AMOS, in AMOS, definitely it's very difficult to deal with category variable. And indeed, we can conduct analysis to dealing with category variable in AMOS, but the results will be show a different way. That means that they won't tell you the model fits. They won't tell you a lot of information, traditional information that we need, because they use the Bayesian estimation. Okay, that will be around many times, and it take a long time. So basically, we in AMOS, it's not a very good software to deal with a latent variable with a category variable. So basically, if you want to deal with category variables in a structural equation model and in AMOS, there is another software we call M+. M+, they have functions. You can insert this kind of functions to deal with a category variable in structural equation modeling. Yeah. So in AMOS, this is the limitations. Yeah.
Yeah. Thank you.
Thank you.
May I know any questions from the audience again?
Yeah, I see there is a chat question, a question from chat. He asked a question is that, hello, I am Wika, second-year student in AHS. Thank you for your topic. I want to ask if we have a sample below 200, can it be forced to use structural equilibrium modeling, or it is better switch to regressional path? Basically, it depends on how many latent variable and observed variable in your structural equilibrium modeling. I highly recommend you can use a power analysis to calculate this 200 sample size will be enough or be okay to analysis your structural equilibrium modeling. Okay, but basically, 200 sample size 200 is pretty. We say this is a small sample size. Basically, if you want to use a structural equilibrium model with a latent variable, that will more likely be a big issues. But it doesn't mean that you cannot conduct a structural equilibrium model, but you can use the structural equilibrium model with path analysis. That means that you cannot analysis in structural equilibrium model with latent variable, but you can use a structural equilibrium model with a path analysis. What is the structural equilibrium model with the path analysis? It basically is similar to the model that I show you, but the different thing is that there is no latent variable in your model. There's only observed variable in your model. Basically, AMOS can deal with path analysis using a structural equilibrium model way to make analysis. So for your question, I would say yes, maybe it will be better you can use regression, but much better if you can use a structured equation model with path analysis. Yeah. Thank you very much.
Thank you. I think because of time, okay, we may now let the students to freely ask any questions, okay? Again, I think if the students have anything wants to discuss, I think Dr. Chen will be welcome you to send him email to ask the questions about using the AMO, something like that.
Yeah, welcome to email me if you have any questions. Yeah, thank you.
Yes. Okay, I think we should give a big hand to Dr. Chen. Thanks him for providing this brilliant talk to us. Okay, thank you.
Thank you, Professor Lim. Thank you, everyone. Thank you. Okay.
Okay, bye-bye.
Bye-bye, bye-bye, bye-bye.